Welcome to our journey through the fascinating history of programming. From the early days of mechanical machines to the sophisticated software of today, let's explore how programming has evolved over the years. Our story begins in the 19th century with Charles Babbage, often referred to as the father of the computer. Babbage designed the analytical engine, a mechanical general-purpose computer. But it was Ada Lovelace, an English mathematician, who wrote the first algorithm intended for implementation on a machine, making her the world's first computer programmer. Lovelace's visionary ideas laid the foundation for the field of computer science. As we move into the early 20th century, we see the development of the first electromechanical computers. During World War II, the need for code-breaking machines led to the creation of the Enigma machine and its decryption by Alan Turing and his team. Turing's work not only helped win the war but also laid the groundwork for modern computing with his concept of the Turing machine, a theoretical device that could simulate any computer algorithm. In the 1940s, the world witnessed the birth of electronic computers. The Electronic Numerical Integrator and Computer, or ENIAC, was one of the first fully electronic general-purpose computers. Programmers like John Bartik and her colleagues wrote complex programs using machine code, a tedious and error-prone process. This era marked the transition from mechanical to electronic computing, significantly increasing the speed and efficiency of calculations. The 1950s brought significant advancements with the introduction of high-level programming languages. Grace Hopper, a pioneer and computer scientist, developed the first compiler, which translates human-readable code into machine code. This led to the creation of COBOL, a language designed for business applications. Around the same time, John Backus and his team at IBM developed Fortran, the first high-level language for scientific and engineering calculations. The 1960s and 1970s were a period of rapid innovation in programming. The development of operating systems like Unix provided a robust environment for software development. Languages like BASIC, designed by John Kemeny and Thomas Kurtz, made programming more accessible to students and hobbyists. Meanwhile, the creation of C by Dennis Ritchie at Bell Labs revolutionized systems programming, offering a powerful and flexible language for developing operating systems and applications. The 1980s saw the rise of personal computers, bringing programming into homes and schools. The introduction of user-friendly languages like Pascal and the popularity of Microsoft BASIC on early PCs like the Apple II and IBM PC empowered a new generation of programmers. Additionally, object-oriented programming, OOP, began to gain traction with languages like Smalltalk and later C++, offering a new paradigm that focused on organizing code around objects, rather than procedures. The 1990s marked the beginning of the Internet age, transforming how we think about programming. Languages like Java, developed by James Gosling and his team at Sun Microsystems, promised write once, run anywhere capabilities, ideal for the burgeoning web. Meanwhile, scripting languages like JavaScript, created by Brendan Eich, and PHP, developed by Rasmus Lerdorf, made dynamic web development possible, laying the groundwork for the interactive web applications we use today. The 2000s and beyond have been characterized by the open source movement and the mobile revolution. The release of open-source operating systems like Linux, led by Linus Torvalds, and collaborative platforms like GitHub democratized software development. Mobile programming took center stage with the rise of smartphones and tablets, leading to the development of languages and frameworks like Swift for iOS and Kotlin for Android. The popularity of cloud computing and artificial intelligence further expanded the horizons of what programmers could achieve. As we look to the future, programming continues to evolve at a rapid pace. New languages, tools, and paradigms emerge, addressing the challenges of modern computing. The rise of machine learning, quantum computing, and blockchain technology promises to transform industries and create new opportunities for innovation. One thing is certain: the history of programming is still being written, and the possibilities are limitless. Thank you for joining us on this journey through the rich history of programming. If you enjoyed this video, please like, subscribe, and hit the bell icon for more fascinating insights into the world of technology. Until next time, happy coding!